Okay, I'm going to go over the second part of periodic trends. So last week, or yesterday rather, we went over atomic radius trends. We saw that going down the periodic table, atoms get bigger because we are adding an extra energy shell. And as we go to the right, they get smaller due to an increase in effective nuclear charge. In other words, an increase in protons, which attract the electrons to the nucleus. So they attract these electrons, making it smaller. Okay, so these are two new trends. We're grouping them together because they're very similar. So if you understand one trend, you should understand the other. Ionization energy is going to be the energy needed to remove an electron from an atom. It should be slightly more specific. I would add a valence electron. So it's the energy needed to remove a valence electron. Let's look at the trend for this. When you go across a period, we have the same number of energy levels. However, we are adding more protons. When you add more protons, you increase the effective nuclear charge. Therefore, these outside electrons are held more tightly. If they are held very tightly, it's hard to remove them, so it takes a lot of energy to remove them. Therefore, when you go to the right, the additional protons cause an increase in ionization energy. Another way to say that is when you go to the right, the extra positive charge holds the electrons tighter, making it more difficult for them to be removed. When you go down a group, we have a decrease in ionization energy. What does that mean? That means it is easier to remove outer electrons. Why is that the case? Well, when we go down, we're adding energy shells. When you add energy shells, your valence electron gets further and further from the nucleus, so further from the positive. Therefore, it's less attracted to the nucleus and it is easier to remove, so our ionization energy goes down. Less energy required to remove it. This is our trend here. Ionization energy increases going this way and it decreases going down. Okay. Another way you can think about it is this would have the highest ionization energy, this would have the lowest. So ionization energy increases going in that direction. Okay, let me show you here. So ionization energy increases going in to the top right. Okay, largest ionization energies are here, smallest ionization energies are here. Okay, electronegativity is a very similar concept but slightly different. When two atoms are bonded, they tend to share electrons. Electronegativity is a measure of how strongly one atom pulls on those electrons. So if an atom is very positive, it really wants to pull those electrons. Let's look at the trend. Across a period, across the table, electronegativity increases. We have the same energy, the same number of energy levels, but the additional protons are going to attract those electrons more. So this atom is going to hold on to the electrons greater because of that additional positive charge. So as the electrons get held closer to the nucleus, they want to hog the electrons. Going down the table, atoms become less electronegative. Why? Because electronegativity refers to how much are we pulling that outside electron. Well, if the outside electron gets further away, we can't really pull on it because it's not very attracted. So the further the electron goes out, the electrons on the outside get so far away that the nucleus cannot attract it. Therefore, it will have a low electronegativity, a low pull on those outside electrons. Okay, so if you notice, this is the same trend as this. Okay? There is one exception though, which are the noble gases. These noble gases, this is a chart that tells you electronegativity. So fluorine is the most electronegative atom, with cesium being the least. The noble gases are not electronegative at all. So remember, electronegativity means you want to pull electrons. These do not want to pull electrons towards them. Why? Well, they already have 8 valence electrons. They are happy, it's stable, there's no need to take or remove. So they are not electronegative, they do not follow the trend. They do follow the trend for ionization energy, but they do not follow the trend for electronegativity. Okay. Here are a few examples. Which has the greater ionization energy? Which one would be harder to remove? Let's work through just 2 examples here. Let's look at magnesium and calcium. Magnesium is here, calcium is here. Magnesium would have a higher ionization energy because it is a smaller atom, therefore it is harder to remove the electrons. What about lithium or fluorine? Which one would have a greater ionization energy? In other words, which one would it be harder to remove an electron from? Well, lithium and fluorine are in the same period there. Therefore, the one with the